I'm going to do the first few problems, and without talking about any rules of finding antiderivatives, but so let's go ahead and start with number one. We're trying to find the integral from 1 to 2 of x squared, keeping in mind that x squared looks like this. 1 is here, 2 is here. So what we're really finding is the exact area now between the curve and the x-axis, the net area between the curve and the x-axis. Net meaning area above minus the area below, within the interval specified by the lower limit of integration to the upper limit of integration. Okay, so here's our theorem up here, the fundamental theorem of calculus, part 2, and the theorem says that the integral from a to b of f of x dx is the antiderivative at b minus the antiderivative at a. And so our goal here is to figure out what is an antiderivative of x squared. So in other words, the derivatives, we have to think here, the derivative of something is equal to x squared. Oops, cut it off a little bit for you. So the derivative of something is x squared. Well, what's that something? We know it's got to be something with an x cubed, because then we have the derivative of x cubed would be 3x squared. Oh, well, if we divide that by 3, then we'd divide that by 3, and we'd get x squared. So the actual antiderivative would be x cubed over 3. Okay, so if you're in doubt, check that out. You've got the derivative of x cubed over 3, which would be 3x squared over 3, which when the 3's cancel, you just get x squared. Don't worry, I'm going to provide you with some rules, but I want to see if you can figure out what those rules might be before I tell them to you. Okay, so here's how we do this. We write it like this. The integral from 1 to 2 of x squared dx is equal to the antiderivative, or an antiderivative, x cubed over 3, evaluated from 1 to 2. Okay, that's just the notation that we're going to be using. Okay, and that notation just says again that this integral has a value of, and I should probably kind of cordon off this other area here. This is our thinking step here. This has nothing to do with the problem. All we're doing is, with this information over here, is trying to come up with an antiderivative like we know we need to have. Okay, so x cubed over 3 evaluated at 2 first means we want to write down, we want to substitute 2 for x, and we want to write down 2 cubed over 3 minus, now 1 in for x, 1 cubed over 3. Okay? By the way, if this were the AP exam and you had to do this, you would leave it just like that. Put a box around it. You don't have to simplify anymore on the AP exam. Okay, but here you do. So we have 2 cubed is 8. So we have 8 thirds minus 1 cubed is 1 minus 1 third is equal to 7 thirds. And that, ladies and gentlemen, is how you evaluate a definite integral. 7 over 3. Okay? Let's try a different one. Let's try number 2. With a little bit of work, and you'll just have to take my word for it. Pause the video if this gives you a problem. Okay? But an antiderivative of 3x squared, we just said that the derivative of x cubed was 3x squared. So we have x cubed, which would be our antiderivative of 3x squared. Okay, because the derivative of x cubed is 3x squared. Okay, minus. Then what the derivative of something is negative 2x. Well, the derivative of x squared is 2x, and when we put a minus sign in front of it, we would have the derivative of negative x squared is negative 2x, just like we have there. Okay. So right here is what my capital F of x is, just like over here. This is the capital F of x. Okay. And we need one more term though. The derivative of something is negative 1, and that derivative of that something is negative x. So the derivative of negative x is negative 1. Okay? And so we're going to evaluate this antiderivative. This is our capital F of x, whereas this guy right here is our lowercase f of x. So the derivative of capital F is lowercase f. Okay? Pause the video and check it out if you're not in full agreement of that, or if you're still in doubt. Derivative of x cubed is 3x squared, the derivative of negative x squared is negative 2x, and the derivative of negative x is negative 1. Okay? Maybe you're starting to see a pattern, but we're going to keep going. We evaluate that antiderivative at 3 first and then at negative 1, so from negative 1 to 3. And that equals, and we're going to use some, got to cordon this off as well. Okay, that is no longer part of our problem. Okay, so this expression here is the antiderivative evaluated from negative 1 to 3, which is equal to, put a 3 in for all these guys, 3 cubed minus 3 squared minus 3, and then minus, be careful here, remember it's capital F, antiderivative evaluated at the upper limit, minus the antiderivative evaluated at the lower limit. So there's a lot of minus signs in here and a lot of places to make mistakes. Okay, but that's the expression, and since I don't have a whole lot of room here, I'm going to try to do a lot of this in my head right now. 27 minus 9. 27 minus 9 is 18. 18 minus 3 is 15. Minus. Okay, this is tough. We've got negative 1 cubed, which is negative 1. Negative 1 squared is 1. And then we have a plus plus because this is minus minus. So we have negative 1, minus 1, plus 1. So this is just negative 1. So we have 15 minus negative 1, which is 16. Okay? We're going to do something right now that we need to do, because you need to know how to actually find these values on your calculator. So get your calculator out, pause the video if you don't have your calculator handy, and I'm going to show you how to do this. The lighting is really not very good right now, so I do apologize in advance for any faulty video footage here. But I want you to go ahead and go to, gosh, really not good. Go to your y equals, clear, and type in the function. So, okay, you can see the function there, your lowercase f of x, and that's 3x squared minus 2x. So we're going to use our calculator to figure out if we got that right. Remember, the answer is 16 minus 1. Okay, that's our function, that's our y1. Okay, we're going to quit that screen, and now we're going to go to math, and you're always just going to remember math 9, but if you scroll down, you can see that math 9 is FNINT or something like that. I think most calculators that I've seen have the FNINT. Well, that would be the integral feature of your calculator, and you're going to hit enter. Okay. Some of you are lucky enough to have a calculator that has this. Okay, this is much easier than having to remember how to do it a different way, and I'll show you how to do it the different way in a minute. So I can't pause this when I'm making videos on my iPad. I can't pause it, otherwise I would do that. But you can see the lower limit of integration sitting there blinking. Type in -1 for that, and then hit the right arrow. Don't hit enter. The right arrow jumps you up to the upper limit of integration, which we know to be 3. Okay? Right arrow, and now the function lowercase f of x, or whatever the integrand is going to go right there, and we already determined that we already defined our y1 to be our function, our integrand. So we're going to recall our y1, or we're going to upload it to the screen here. And that goes, the way we do that is we push the vars button, which is to the left of the clear. Vars, we should know how to do this anyway. And then right arrow, y variables, enter. And then we just select the y1. And it puts it right there in a nice place. Okay? And then dx, our independent variable, goes there. And we hit enter. And we get 16. Alright, we did it right. Okay. For those of you that have the different calculator, the one that's not super fancy like that, it's more the newer model. I'm not bagging on your calculator if you've got one of these guys. Okay, so apparently that's not going to work. I'll have to show you in class how to do that because this calculator's out of batteries. So not only is it an older model, but it's also out of batteries, and I don't, like I said, I can't pause the video. So why don't you do this? Why don't you practice that process with problem number 1 as well, and just show that you can get 7/3. And if you want to pause the video, great. Just make sure you can get 7/3. What I'll do is I'll do the problem right now. So if you're wanting to pause the video, then do that right now. We're going to put x squared as our y1, and then we can second entry. If you're doing a lot of integrals, you can just go back and change the limits of integration. Limits of integration in that problem were from 1 to 2. Okay, and we already have the y1 there, so we don't need to change that. Enter, and we get 2.33, and they're like, oh man, is that 7/3? Well, yeah, it is, but to confirm that, push your math button. Okay, math is right underneath the green one. Math button, and then notice that the selection is take your answer and change it to a fraction. If it is a rational number, it'll do that. Answer, change it to a fraction if possible, enter. Sometimes it works, sometimes it doesn't, even if it is a rational number. I think I may have said rational function. But you can see here clearly that it did, in fact, change our 2.33 and so forth into 7/3. So that is how you do that, and then I will pick up the rest of this in the next video.